A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. So, imagine this. It is 2 in the morning. You are fast asleep, and your production AI agent, the one handling your customer support or your automated scheduling, suddenly loses its mind. It starts throwing errors left and right. Why? Because a third-party developer updated their Modal Context Protocol server and renamed a single parameter from user_ID to user_ID.
That is the nightmare scenario, Corn. And honestly, with the way MCP adoption is exploding here in early 26, it is becoming a daily reality for a lot of developers. Today's prompt from Daniel is hitting on exactly this friction point, the gap between how fast server authors are shipping updates and how stable we need our client applications to be. By the way, just a quick heads up for the listeners, today's episode is powered by Google Gemini 3 Flash.
It is the classic velocity versus stability trap, right? Herman, for the folks who are building these integrations, how does an MCP server even tell a client what it can do? I mean, we talk about tools all the time, but what is actually going across the wire when an agent discovers a new capability?
It is all about the tools /list endpoint. When a client, whether that is Claude Code, a custom chatbot, or an enterprise orchestrator, connects to an MCP server, the first thing it does is ask for a manifest. The server responds with a JSON RPC message containing an array of tool definitions. Each tool has a name, a natural language description, and most importantly, a structured definition called an input schema.
And that schema is written in JSON schema, right? The same stuff we have been using for web APIs for years.
Precisely. It defines what fields are required, what types they are, strings, integers, booleans, and often includes descriptions for each individual parameter. The problem Daniel pointed out is that while this discovery happens at runtime, many developers are still writing their client-side code as if those schemas are set in stone. They hard-code the expectation that a search tool will always have a query parameter and nothing else. The moment that server adds a required filter parameter, the hard-coded client breaks.
It is like trying to plug a USB-C cable into a port that someone sneakily replaced with a VGA connector overnight. You think you know the interface, but the physical reality has shifted. Why is this happening so much more with MCP than with traditional REST APIs? We have had API versioning solved for a long time, haven't we?
We have, but the philosophy of MCP is different. Traditional APIs are built for humans to write code against. You read the documentation, you write the integration, you test it, and you deploy. MCP is built for AI models to use. The discovery and schema mechanism is designed to be consumed by an LLM at the moment of execution. Because it is so easy to spin up an MCP server and add a new capability, developers are treating them more like living documents than rigid contracts. They are shipping updates weekly, sometimes daily, and they assume the intelligence on the other end of the pipe will just figure it out.
But that is the rub, isn't it? The intelligence might figure it out, but the plumbing, the code we write to bridge the LLM to the tool, is often quite brittle. If I have a UI with a specific button that triggers a specific tool call, and that tool call signature changes, my button is now a paperweight.
That is exactly where the friction lives. We are seeing a fundamental tension between the server's desire to evolve and the client's need for a predictable interface. If we look at the actual mechanism of these breaking changes, it usually boils down to 3 things: renaming parameters, changing a parameter from optional to required, or fundamentally altering the structure of the return data. Even though MCP has versioning, The current spec is version 24.11.05. That versioning mostly covers the protocol itself, not the specific implementation of every tool on every server.
So let's dig into that. If I'm a developer and I don't want to be woken up at 2 a.m., how do I build something resilient? Daniel mentioned this idea of the chatbot using its own intelligence to navigate these changes. Is that actually feasible in a production environment where we usually want high predictability?
It is not only feasible, it is becoming the recommended pattern. But to get there, we have to move away from what I call static integration and toward dynamic adaptation. Think about how OpenAI handles function calling. They provide the model with the tool definitions in every prompt. The model reads the description, looks at the parameters, and generates the call. If the tool changes, the model gets the new description in the next turn and adjusts. The breakdown happens when we try to put a smart model inside a dumb wrapper.
Right. If my wrapper code is validating the model's output against a cache schema from last month, it will reject the model's correct new call because it thinks the model made a mistake. It is like the model is trying to use the new VGA port, but the wrapper is still yelling that it doesn't see a USB-C plug.
You have got it. That brings us to the first big pattern for resilience, schema-aware client adapters. Instead of hard-coding your tool calls, you should be building a layer that performs live validation and transformation against the current schema provided by the server. When the client connects, it should refresh its tool list. If it detects a change in a tool it relies on, it shouldn't just crash. It should use an internal mapping logic to see if the change is something it can handle automatically.
Give me a concrete example of that. How does an adapter handle a change?
Let's take the weather server example from Daniel's notes. Say you have a tool called getWeather. In version 1.1, it takes a parameter called location. In version 1.2, the author changes it to location query because they want to support zip codes and coordinates more explicitly. A resilient client would have a mapping layer that says, I'm looking for location, but I see location query. Based on the description, these are semantically equivalent.
Wait, are you suggesting we run a mini LLM call just to map parameters? That sounds like a lot of latency and a lot of cost just to fix a typo in a server update.
Not necessarily. You can use a lightweight embedding match or a simple semantic lookup table, or, even better, you can lean on the primary LLM's reasoning. If you pass the updated tool definition directly to the model, it will see location query and use it. The only thing you have to ensure is that your UI or your backend logic isn't blocking that correct output because it was expecting the word location. This is what we call internal diversion management. The model handles the pivot, and the user never even knows there was a schema mismatch.
I like that. It is basically letting the AI be the glue code. But what about when the change is more significant? Like, what if a tool that used to return a simple string now returns a complex JSON object with nested arrays? No amount of parameter mapping is going to fix a broken data pipeline downstream.
That is where pattern 2 comes in, dynamic discovery with caching and retry logic. A production-grade MCP client shouldn't just assume the tools are what they were 5 minutes ago. It should implement a stale while revalidate pattern. It uses the cached version of the tool for speed, but if the tool call returns a 4000 level error, specifically a invalid params or schema mismatch error, the client should immediately trigger a refresh of the tool's /list.
And then what? Does it just tell the user, sorry, the server changed, try again?
No, that is where the agentic loop kicks in. The agent should catch that error, look at the new schema it just fetched, realize what changed, and then reattempt the tool call with the corrected parameters. This all happens in the thought phase of the agent. To the user, it just looks like the agent took an extra second to think. In reality, the agent just performed a self-healing operation on its own integration.
That is actually quite elegant. It is like the agent is its own DevOps engineer. Oh, the API changed? No worries, I'll just rewrite my request on the fly. But Herman, isn't there a risk here? If we allow agents to autonomously navigate these changes, could they end up calling tools in ways we didn't intend? Like, if a delete tool adds a confirm parameter and the agent just says, sure, true, without asking the human.
That is the human in the loop dilemma Daniel mentioned, and it is a massive point of discussion in the MCP community right now. There has to be a distinction between structural changes, like renaming a field, and behavioral, Changes like adding a parameter that changes the scope of an action. A resilient client needs a policy engine. You might allow the agent to autonomously map user ID to account ID, but you explicitly forbid it from mapping an optional force delete parameter to true without human intervention.
It sounds like we need a more sophisticated way of tagging these tools. Maybe the MCP spec needs to include risk levels or sensitivity scores in the tool definitions.
Some people are pushing for that. Currently, we rely heavily on the description field, but you can imagine a world where the server provides metadata about which parameters are safe for AI-mediated mapping and which ones require a hard contract. Until then, the burden is on the client developer to build those safeguards.
Let's talk about the front end for a second. Daniel mentioned generative UI or GenUI. I've seen some of this with frameworks like Copilot Kit. The idea is that the server doesn't just send data, it sends instructions on how to render that data. How does that help with the versioning crisis?
It is a game changer because it moves the contract from the code to the protocol. If the server defines the UI, then the client doesn't have to know anything about the underlying data structure. Imagine a send email tool. Instead of the client building a form with two subject and body fields, the client asks the MCP server, how should I display the input for this tool? The server sends back a declarative UI schema. Maybe it is a list of components or even a React snippet.
So if the server author adds an attachment field, they just update the UI schema they send back, and the client's form automatically grows a new upload button?
The client is just a dumb renderer for the server's smart UI definitions. This is the ultimate way to decouple server velocity from client stability. The server can change its internal logic, its parameters, and its UI every hour. And the client will always stay in sync because it isn't hard coding anything. It is the thin client model applied to AI agents.
It is funny, we spent decades moving away from thin clients toward rich, heavy client apps, and now AI is pushing us right back. It makes sense though. If the interface is too complex for a human to keep up with, let the machine handle the rendering. But Ermin, doesn't this create a latency tax? Every time I want to show a button, I have to do a round trip to the MCP server to ask what the button looks like.
There's definitely a trade-off. You are trading a bit of latency and bandwidth for massive gains in maintainability. However, you can mitigate that with aggressive caching of the UI schemas. You only refresh the UI definition when the underlying tool version increments. This is where semantic versioning in tool names comes in. If a server offers search_v1 and search_v2, the client knows exactly when it needs to fetch a new UI definition.
I've also seen some talk about MCP gateways. These act as a sort of proxy or buffer between the client and the Wild West of third-party servers. Is that a viable strategy for enterprise users who can't afford any downtime?
It is arguably the most production-ready strategy right now. A gateway allows you to pin specific versions of MCP tools. Even if the third-party server updates to v2.0, the gateway can continue to expose a v1.0 compatible interface to your client by performing the transformations itself. It gives the client team time to test the new version in a staging environment before promoting it to production.
It's basically a firewall for your AI's capabilities. I like that. It feels like the adult in the room when everyone else is just shipping fast and breaking things.
It is. But it also highlights the agentic friction we talked about way back in episode 1076. Remember when we discussed the restart tax and the plumbing of the agentic age? This versioning crisis is the next layer of that friction. It's not just about keeping the connection alive, it's about making sure the connection is actually useful once it's established.
I remember that. We were talking about how much overhead there is just to keep these agents running. It feels like we are in this awkward middle phase where the protocols are powerful, but the implementation patterns are still being written in blood, or at least in late-night PagerDuty alerts.
That is exactly where we are. We are moving from AI as a feature to AI as an infrastructure. And infrastructure requires a level of resilience that we haven't quite mastered yet in the agentic space, but the tools are there. If you use dynamic discovery, lean on the LLM for semantic mapping, and explore declarative UI patterns, you can build a client that is remarkably robust.
So, if I'm a listener and I'm building an MCP integration today, What is the one thing I should change in my code right now?
Stop hard-coding your parameter validation. Seriously, if your code does a check like, if params contains exactly these 5 keys, proceed. You are asking for a production outage. Instead, build a permissive validation layer. Check for the minimum required fields, but allow the model to pass extra fields if the server's schema says they are allowed. And for heaven's sake, log your schema mismatches so you can see when a server is drifting away from your expectations.
It is like that old Postel's law for networking. Be conservative in what you send and liberal in what you accept. It applies to AI tool calls just as much as it does to TCP packets.
It really does. And I think we're going to see this evolve into more formal tool registries. Imagine a central place where MCP server authors can register their schemas and clients can subscribe to breaking change notifications. We are already seeing the beginnings of this with things like the Smithery registry and the community-driven MCP Git tools.
That would be a huge help. But even with the registry, you still have the problem of the long tail of niche servers. I mean, Daniel mentioned his own work in automation and tech comms. If he writes a custom MCP server for his specific workflow in Jerusalem, he is probably not going to register it on a global registry. He just wants it to work with his local agent.
And for those local niche use cases, the AI as the adapter pattern is even more important. Because you are the one controlling both ends of the pipe, you might be tempted to be lazy and skip the versioning. But 6 months from now, when you've forgotten how you wrote that server, you'll be glad you built the client to be flexible enough to handle its own creator's forgetfulness.
I feel attacked by that last comment, Herman. I've definitely broken my own tools more times than I'd like to admit. But you're right. The future me is the most frequent consumer of my present me's broken code.
We have all been there. One thing that really struck me in Daniel's notes was the comparison to USB-C for AI. The idea is that the MCP protocol should never change, even as the devices, the servers, get more complex. If we can achieve that, we can reach a point where building an AI agent is as simple as plugging in a peripheral. You don't need to know how the camera works to use it on your laptop, you just need the OS to recognize the USB-C standard.
I love that analogy, comparison. It makes the whole thing feel much more manageable. It's not about predicting every change. It's about having a standard that can accommodate change.
Wait, that is the core of it. We are building the operating system for AI agents, and MCP is the driver model. If we get the driver model right, the ecosystem can explode without everything constantly crashing.
Well, I think we have given people a lot to chew on. From schema-aware adapters to GenUI and the agentic retry loop, there are plenty of ways to close that velocity gap. Herman, any final thoughts before we wrap up?
Just that this isn't just a technical problem, it is a mindset shift. We have to stop thinking about APIs as static contracts and start thinking about them as dynamic conversations. Once you embrace that, the crisis of versioning starts to look more like an opportunity for the AI to show off what it is actually good at, navigating ambiguity.
Navigating ambiguity? That is basically my life as a sloth. I feel very seen right now.
I knew you'd find a way to make it about being a sloth, Corn.
It is what I do. All right, let's get into those practical takeaways for the folks listening. If you are a developer, what should you actually do on Monday morning?
First, audit your current MCP integrations. Are you hard-coding tool schemas? If so, start moving toward dynamic discovery via the tools/list endpoint. Second, implement a basic retry on schema error loop in your agentic logic. It is a low-effort, high-reward way to handle minor server-side updates. And third, if you are building the front end, look into schema-driven UI generation. Don't build a form for every tool, build a component that can render any JSON schema.
And if you are a server author, maybe think twice before you rename that parameter just because you like the look of camel case better than snake_case. Think of the poor developers and the poor sloths. You might be waking up at 2 in the morning.
A little empathy goes a long way in API design.
It really does. This has been a great deep dive. It is one of those topics that feels a bit in the weeds until your production system goes down, and then it is the only thing that matters.
Those are often the most important conversations to have. Thanks for pushing me on the human in the loop side of things, Corn. It is easy to get caught up in the technical elegance of self-healing systems and forget about the safety implications.
That is why I'm here. To slow you down just enough to make sure we don't accidentally let the AI delete the internet because someone updated a schema.
I appreciate the speed break.
Anytime. Well, that is about all the time we have for this one. We have explored the versioning crisis, the patterns for building resilient clients, and why your AI agent might be the best DevOps engineer you never hired.
It is a brave new world of agentic infrastructure.
It sure is. Huge thanks to our producer, Hilbert Flemingtop, for keeping the gears turning behind the scenes. And a big thanks to Modal for providing the GPU credits that power this show and keep our resident AI scriptwriter running smoothly.
We couldn't do it without them.
If you enjoyed this dive into the plumbing of the AI age, we would love it if you could leave us a review on your podcast app of choice. It really does help other curious minds find the show.
And you can always find us at myweirdprompts.com for the full archive and all the ways to subscribe.
We are also on Telegram. Just search for My Weird Prompts to get a ping every time we drop a new episode.
Until next time, keep your schemas flexible and your agents curious.
This has been My Weird Prompts. See ya!
Goodbye.
This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts.